All right, 2.7, use absolute value functions and transformations. All right, so with this we have a lot of graphing stuff. I'm not particularly worried about us graphing them. I mean, you should know what an absolute value function looks like in terms of its graph, and I'll show you that in just a minute. But other than that, we'll just be talking about how the things are shifted. So a lot of your homework, rather than graphing them, it'll be to tell me what direction things are moving. So anyways, that being said, the parent function for absolute value functions is f of x is equal to the absolute value of x for this, the vertex is at 0, 0. And just a picture of what the absolute value function looks like. It's just a v. And that's really all you need to know about the parent function. That's as much as you need to know about the graph. It is possible on like your quiz or test, I may ask you to just draw me a picture of the parent absolute value function, draw the graph of it. If I say that, that's all I need right there. But as far as the transformations of them, so for the transformation, we can have a translation which shifts it either up or down, left or right, and then we can have a stretch, shrink, or reflection. And so we'll talk about all of those things and what that means. I'm just going to try to lump everything all in one here as best I can and label stuff. I'm going to kind of spread out the function so we can write in all around it what things are. So basically we have y is equal to a times x minus h plus k. Alright, so labeling this stuff, I'm going to try to do this with a smaller marker so it's just easier to see what's going on. K is going to be the shift up and down. And for K, it shifts in the direction of the sign. Okay, so meaning if K is positive, my graph goes up. If K is negative, my graph goes down, the whole thing. Okay, with H, okay, this is what causes the graph to shift left and right. So it shifts right and left. It shifts in the opposite direction of the sign. Okay, so when it's negative like this, it goes to the right. When it's positive, it goes to the left. X is obviously just the initial function, and then whatever's happening to it. A, though, has to do with the stretching or compressing. Okay, and so from that, if A is, and this is going to be the absolute value of it, okay, so the positive value, for A greater than 1, it is stretched. For A less than 1, it is compressed. Okay, so if A is a fraction, it's compressed always. Okay, some people say shrunk. I want you to say stretched or compressed, just so that we're clear on that. Now, if I were to have y is equal to minus a x minus h plus k, okay, then this sign here, the negative, flips the graph upside down. So the way you would write that to tell me what's happening is you would tell me that it's being reflected. Okay, and notice h is always going to be inside the absolute value, and that's always going to be the right or left. If it's inside, if it's outside, then it's going to be the up or down. But just know that every problem doesn't have to have all of these features. Okay, some might just be y is equal to the negative times absolute value of x. Okay, and all you would have to tell me there is that it's reflected. If it just has an a in front of the x, it just says y is equal to 3 times the absolute value of x. Okay, then you would tell me that it is stretched. And that's all you're having to tell me. Okay, you're comparing it to the parent function. So we are going to do them differently than the book. And then something that's a little more challenging, but I know we can do, is we're going to also do it by looking at a graph, figuring out how things are shifted, and then writing the equation, so doing the reverse. Being given the equation, we would be able to tell where it shifts, but then seeing a graph, writing down the way that it shifted, we should be able to then come up and make an equation like this. So we'll do it both directions, and that's pretty much all we're going to do with this. Like I said, you're not going to be graphing them unless you're just so ambitious to do so. But that is really all we're going to cover in this section here. Not really even going to look at anything else. So.